So here's another example where calculator deceives you if you try to rely on calculator blindly. So here is example of a limit. Limit as x approaches 0, sine of pi divided by x. Again, let's try to do it numerical, and since x approaches 0, once again we know what x values we want to plug in, and let's try like we always try. So 0, 0.1, 0.01, 0.2 zeros 1, 0.3 zeros 1. And if we try to use calculator as before, so press y equals and clear the previous function, type in this function, sine of pi divided by x. Again, you have to make sure that your calculator is set up on radians and not degrees. Now go to the table, second table, and if you plug in 0.1 into this formula, then you end up 0. 0.01 you end up 0. 0.00, all of them actually end up exact 0. And if you think that it's approximate, no, it's not approximate, because when you put a cursor on top of this 0, so down the screen you will see again 0. So those zeros are precise numbers. So what I want to say, if you watch this y values, you can say that it looks like function values approach 0, and therefore the limit equals 0. So let me write what I just said. So it looks like the limit equals 0. But in fact, it is not so. If you try other x values, carefully chosen x values, you will see that the limit actually is not 0. And now the x values that I actually want to try for this example are following. X, y, 1. So the x values that I want to try will be the following. So 0.3, 0.13, 0.013, 0.0013, so 0.00013, etc. So, like you see, every next x value is 1/10 of the previous x value. So they are still, each next x value is smaller than the previous, and they all approach 0. So x values still approach 0. But let's try to erase those x values. And instead enter the x values that I just wrote down. So 0.3, and suddenly we have absolutely different answer. We get negative 0.866. If you try 0.13, we got negative 0.823. Seems like it approaches, at least seems like the first digit is 0.8, negative 0.8. But let's try some more. So 0.013, the answer is suddenly 0.23932, which is very strange. So try some more. 0.2013, the answer is negative 0.6631. So if we plug in number 0.0013, then we get function value negative 0.6631. And again, you can see that it has kind of no relation to the previous function values. Let's try just one more. If we try 0.3013, then the answer that I got here is 0.82298, which again has no relation to the previous values. And what it means that the function values do not really approach any value like it was before, 12 or even some ugly value. Those do not approach even an ugly value. They just jump up and down wildly. So let me write this. So function values do not approach anything. And And when this happens, we say that the limit has no value. There is no value, and so we say limit is undefined, or DNE for does not exist. Now, once again, if you rely on your calculator blindly, just put the most obvious x values that approach 0, then it looks like the limit is 0. But if you try some other x values, then it seems like limit is in fact undefined. So what I want to say is that you can't really blindly trust your calculator. You have to think more and try some more values, and then later we will study some other methods that how to solve limits like.